Hi, welcome to day 2 of the Advent of Code 2023 in Dart. This one, this challenge, I found it really confusing reading it, but once I kind of understood it, I actually thought this was easier than yesterday's challenge, at least like easier than part 2 of yesterday's challenge. And I'm excited to sort of share what I came up with here. Again, just if you haven't seen the first one, this is essentially just going through the Advent of Code, which is links in the description, but it's a cool daily code challenge in December from the 1st to the 25th, and there's 2 challenges a day. I definitely recommend. Please try these on your own first in whatever language you want. Obviously, I'm doing them in Dart to keep on brand with my channel. But you can use any language that you like, and definitely try them on your own, and then come here to see my solution. Again, my solution might not be the best solution, but I'm here to sort of share stuff and hopefully teach a few things along the way. So this challenge boils down to, you can read through this on your own, but you can imagine there's an elf sort of with a bunch of colored balls, red, blue, and green balls, and essentially, he's pulling out random ones, and it's not really like a guessing game necessarily. It's more about what games are possible given a certain amount of balls. So for instance, in this source of truth here, in game 1, there's multiple rounds in a game, so they're separated by these semicolons here. So in the first round of that game, he pulls out 3 blue balls and 4 red balls, and then he puts them back. And then he pulls out 1 red and 2 green, and 6 blue, puts them back. The next time he pulls out 2, and that's one game. And inside that game, what we're essentially trying to determine is based on, at least in this first round here, if he only had 12 red cubes, sorry, I guess they're cubes, not balls, my mistake. If he only had 12 of them, 13 and 14, which of these games would even be possible? And for instance, in this example thing, 1, 2, and 5 are possible because we never have that many. But you'll see there's in game 3, there's 20 red cubes that come out. And because we're saying there's only a max of 12, it's a problem. Now, what you have to consider is he's putting them back each time. So it's not like we're adding up 20 plus 4 plus whatever and seeing if it's possible, because it sort of like resets in each round. So really we're trying to find out, like, does this ever go over that max number? And the solution for this, essentially what you have to provide is you take all the game IDs. You'll see they have game 1, game 2, game 3, this auto incrementing ID. And we actually take the possible games and any of the possible ones, we sum those IDs together. So we're not actually answering specifically how many games are possible. We want to kind of come up with a sum of the possible game IDs. So it's, I don't know if this would ever be a real world thing, but maybe there's a reason, they're doing that. It's obviously, this is just to make you really think and not miss the information. And something I've noticed is definitely this is kind of like doing like math problems in school when you have there's a lot of information here that you can kind of you want to read because it might be important, but there's a lot you can kind of skip over and be like, that doesn't matter. And I'll point it out in the second one too. There's something that's just like, you're just like, why do we even care about that? And I think it's partly just to distract you essentially. So let's figure this out. So for part 1 of this, again, if you haven't seen my first one, yesterday's challenge, check it out. It's pretty cool. But basically here we're using that same function. I'm provided, when you go through this, you're provided your own data source to work with. So I actually, the way I've kind of been doing this is I have a ground truth for today, which that's the one that they give you in the example. And I just like to play around with that because then I know, if it adds up to, if I get the same answer as they're saying here, there's a good chance I'm doing something right. So I kind of have the December 2nd ground truth, and then I get my own, and this one has 100 games in it. So that's what we're actually going to be submitting our answer with. But I just have this nice little helper here, a constant of whether I'm using ground truth so that I know which file to pull in. That way I just have to, when I'm ready to run the real solution, I would just change this to false, and it would pull the right file. So we're just reading the lines from file. This is just in this helpers folder I made that I'm planning on putting any reusable things that are, not necessarily challenge specific. And I had a feeling that when I did the first day, like, I'm probably gonna need this again, and that's why I put this here. So here's how we're going to do this. So we're going to read that, and that basically gives us back a list of values. So that's really just the text that's in here. So it's each string is from here to here inside a list. And we're passing that into our solve function. And I've also set the solve function to have some constant values in it. So you'll see here, there's the lines that we pass in, but then the max blue, max red, max green. And I had a feeling that maybe in the second challenge, they would, change something. So I wanted to make it a little more dynamic than, that we could just pass in our sort of like initial main function. Obviously, there's a million ways to do this, but we're passing that stuff in. And for this one in particular, I want to do a little bit more of object-oriented programming using some classes because these things can be thought of objects. We have games and we have rounds, right? So the first thing we do is we actually kind of like take those lines, we map through them, and we create a game for every entry. Now, what does a game look like? Well, if we scroll here, we see a game. All I really care about is the ID of the game and what rounds are inside of it. And, we'll just talk about the ID first. So essentially what I do is I have a factory function, and that's what's being called here. We're essentially doing the game from data. And this factory function is expecting, essentially that string to be passed in, as you can see here, this data string. And to get the ID, it's pretty basic. All I'm doing is splitting on the colon here and taking the first value, and then I'm replacing out game space with nothing. So I should be just getting back a 1, a 2, a 3, a 4 in theory. And then I'm wrapping that whole thing in an int.parse, so that is actually an integer as opposed to a string, because that'll make it easier to sum things together later. There's also a thing called rounds, and let's take a look at that. It's a little more complicated, but basically a round has, all I care about is how many blues were in that round, how many reds, and how many greens, so they're all integers. And we have a similar from data function where we're passing in the data. And basically what I'm expecting to pass into here is everything after this. So, actually, the round, I'm passing in just everything between a semicolon, right? That's the data for that round. So in the first game, first round was 3 blue, 4 red, et cetera, et cetera. So assuming that just this is being passed in between the semicolon, we're splitting on the comma, because that's how we know, where the differentiator is between the blues, the reds, the greens, et cetera. And we're trimming it to, we're basically splitting on it, mapping it, trimming the inserts of it so that there's no extra spaces, because we don't really care about the spaces on the beginning and end. And that gets us our entries. And then we're just checking in the entry. And if the entry contains blue, we are essentially just replacing out the blue part so that we only have the number. Same with red, same with green. So just some pretty basic string parsing. I imagine this could all be done with a very smart regular expression, but that is not something that I think will ever be something I'll figure out. So yeah, we're just kind of parsing, and we're just essentially, we start with these values here, blue, red, green, and we are, adding them in, and then we're constructing this round. So that's how we get the rounds. And, essentially to parse that, from that initial game data, we're again splitting on that colon to divide it between, this section and this section. And then we're getting the last part of it because we don't care about the part that has the game ID. And then we're splitting again on the semicolons and converting it back to a list. And that's essentially, we loop through the rounds data and we create a round from that. So pretty basic, just parsing, data and constructing it. So that gives us our lovely thing. I also put these just 2 string functions in here, and this is really good for debugging because if I just wanted to print what the game looked like, I could make sure that it was being parsed correctly. So for instance, print game, and I'll just, throw an exception here so that it doesn't actually run through everything. If I save that and actually run this, we'll actually, I did round 2. So we got, we're just kind of like printing out this way. Game 1, blue, and then I'm dividing each round by this. And that's just the way I, wanted to make sure stuff was good. And I definitely noticed an issue when I did this first. So I'm glad I had this print because I would have probably gone in circles being like, what's wrong? And it was simply because I think I was incrementing blue count all 3 times, no matter what. Just when I did a copy and paste, forgot something. So, recommend doing that in general. Just like having good ways to sort of debug your data in a print statement there. So let's get rid of that. Okay, so basically that's just to explain how we get our games, because that's what I want to work with. I want to work a list of these games because I now have the data in like a normalized way with IntelliSense and stuff. I'm not, parsing in a dictionary or something. So what we need to figure out is how many of these games are possible. So what I want to be storing is specifically the game IDs, because I'm not actually care about how many games. I care about the sum of those games IDs, and that's just what the challenge says to do. So we can, of course, know the number of games that are possible just by counting this list when we're done, but the program doesn't really care about that. So we're looping through the games, and first what I'm doing is I'm just saying, yeah, this game is possible, for sure. And then what I do is I loop through each round. And if at any time in, through those rounds, the blue count is greater than max blue, and again, that's the number they're giving us here, 12, 13, and 14, or the red count's higher than the max red, or green count is higher than the max green, we just simply say, like, the game is not possible. So that loop happens, and if this doesn't ever get set, it will stay as true. But if in any case there's a problem, it'll just go to false, and it will still continue on. Like, we could break out of this loop once we know it's false to optimize this a little bit better. And, maybe if there was 100 million games, that would be a smart idea. But doesn't really make a difference for this 100 game thing. And then what I do is I'm basically taking that possible game IDs and adding something to it. So I'm adding, if the game is possible, I'm taking the game ID, otherwise I'm adding 0. This is just a fancy way of really, I think initially I had like if game is possible, then we would just add the thing over. But this is a little shorthand thing that will either add 0 if it's not possible, which won't affect the number obviously, or it will add the game ID. And then at the very end, all we do is we take the game IDs, and this is just a fancy way of summing a list together. So it's the fold method. In a fold method, you first pass your initial value that you're starting with. Obviously, we want to start with 0 because that's where we want our sum to start. And essentially, this is the function that runs for each element. So it takes whatever has been summed already, whatever the previous case of this operation was, as previous value, and then the new item that it's looping through. So we're just going to keep adding, again, starting at 0. And that ultimately returns an integer instead of a list of integers. And that's what we got here. And if we actually run this without the exception now, we get back 8, which that made me pretty confident that this would work. And I did, immediately then change this to false so that I could run it against my real data and got a number back. And, I kind of just input it in and it was like, you're correct. So I was happy that I got it right. Because I know on yesterday's, in the second part of yesterday's, I was getting the correct answer with the source of truth, but there was some issue with it when you had the larger list, and I had to kind of work back and figure that out. But yeah, this one just kind of worked on my first try after, after obviously solving the ground truth version of it. Okay, so that's the solution for A that I came up with. Again, in the comments, please definitely, send some links and some thoughts, things that maybe I could have done better or a different approach. By no means is this, the best way to do it. I would love to hear what you think. Okay, so part 2. I was expecting part 2 to completely just like change everything and be a really big difference between, part 1, as I felt like it was yesterday. However, I didn't find it that difficult. The difference in part 2 is we're no longer trying to solve what games are possible. We don't care about these red cubes, how the maxes here of this 12, 13, and 14. Instead, what we're trying to figure out is what are the least, in any given game, what are the least amount of reds, blues, and greens that we would need for the game to actually be all games, or each game to be possible. So, for instance, in game 1, just by looking at this, it could have been played with as few as 4 red, 2 green, and 6 blue, because those are kind of the maxes within each one. Again, we're not adding these together because we're always putting these back in at the end of each round, but we know that if the highest was 6, we know that this would at least need 6. It could have 100, doesn't matter, but we know that 6 is the minimum that would be needed for this. And you could, of course, read through this on your own, but that's kind of the idea. And then, the extra layer of math is what they want you to do is when you find out what those numbers are for each round, you multiply them together. So the minimum number of reds, the minimum number of greens, the minimum of blue, you multiply all three of those together, and that gives you a special number. And then you actually take all those special numbers and add them together to get a sum. And in this example, it's 2286. So let's go to the solution for that one now. And I'm going to just put it back to source of truth here, and I'll go over like this. And you know what we're kind of doing here this time, I don't care about those constants, so I'm not passing anything in because there's no like rule like the minimum blues, that kind of thing, but I'm still passing in the same input file. And I actually noticed the ground truth for part 1 and 2 are the same. Yesterday's was actually different ground truths, so you'll see the way I've labeled them. I have A and B ground truth for yesterday, but here I just needed one. I originally called this A, and then when I realized it's the same one, I just renamed it to keep things clean. So running this one now, we'll just change this to B. We'll get back that number that they say it should be, 2286. Cool. So let's walk through how we did this. So again, reading them from the files, and then we're still running that same, getting the game data back. Nothing changed there. I didn't change anything with the models. In theory, I could have moved now these models to a different file because they're essentially duplicated, but I want to, other than these like helper things, I want to keep each of these as like a standalone application. And at the time of starting this, I didn't really know if I would need to make some changes to it. So all we're doing here, we're getting the games, and then I want to keep a sort of a list of those game powers, which is like kind of like the multiplication of the red, green, and blue minimums. And yeah, this was pretty basic. I'm just looping through the games. For each game, I'm starting with setting the max blue, max red, and max green to 0, as one would think. And then I'm looping through each round. And I want to set this value to using this max function, which is really helpful for this use case. What max does is you pass 2 different things in, and it will return you the one that is the largest. So the largest integer in this case. So in the first pass around, max blue will be 0, and it'll be then comparing it to the round up blue count. And this will either be 0, or it might be 1, 2, 3, it might be 100, who knows. And basically what we want to do here is take whatever the largest one is. So this will allow us to, as we loop through, it's not going to change that number until a larger number comes up. We'll do the same with red, we'll do the same with green. And then all I'm doing is, after it loops through all the rounds, I'm just multiplying together the max blue, max red, max green. In theory, sometimes this might end up being 0, because if any one of these is 0 in a full game, we'd be multiplying a 0 in here. But that doesn't matter. We're just following the rules of the challenge, and that is, something that could potentially happen. I didn't even look through to see if that does happen, but it could potentially happen. So yeah, we're just creating this list, and then at the very end, that same sort of thing. We're just basically summing that list together and returning it. So if I run this again with not using the ground truth, I get my real solution. And similarly, I ended up pasting that in without looking too much into, what could I be missing here? But it ended up working, so I was happy with that. So there you have it. That's the challenge for December 2nd. Again, although it's probably too late now, but I definitely encourage you to sign up for this. It's not too late, even if you've missed the first day. Or the second day. By the time you watch this, you can start partway in and still try and do it. And in fact, as far as I know, maybe you can even do previous challenges on, a future date. I'm not actually that sure. So definitely do it. It's a fun challenge. And again, you can use any language you want. I'm using Dart, partly because I love Dart, partly because I've noticed on like the Reddit posts, no one's really, I haven't noticed anyone using Dart. It's a lot of, Python and Rust and Go solutions and stuff like that. And I figure I could fill in a gap there. So thanks again for watching, and we'll see you in the next one.